on linear approximations. By the end of the lesson, you will use linear approximations to estimate the value of a function at a given point. So let's review a little algebra first. To find the equation of a line with slope m, which passes through a point x naught, y naught, we can use y minus y naught equals m times x minus x naught. This is called the point-slope form of a linear equation, and we have already used that to find the line tangent to a function at a point x naught, y naught. Now let's let y equal f of x. Then we can rewrite this equation as follows. First of all, what is x naught? What is f evaluated at x naught? Well, that's y naught. So this equation above becomes y minus f of x naught equals m times x minus x naught. Well, we're not quite done yet. What is this m? Since the slope of the function f at x naught here is given by the derivative of f evaluated at x naught, it follows that m equals f prime of x naught. Okay, so let's keep going. So we have y minus f of x naught equals the derivative of f evaluated at x naught times x minus x naught. And then we can add f evaluated at x naught to both sides to end up with y equals f prime of x naught times x minus x naught plus f of x naught. Okay, now that we've done this little bit of review, let's call this equation A. Now for a warm-up, let's find a tangent line. So we're going to use A to find the equation of the line tangent to f of x equals square root of x when x equals 4. So using A, I know that y equals f prime of x naught times x minus x naught plus f of x naught. First of all, f prime of x, what is that? Well, if you'll recall, we can rewrite f of x as x to the 1/2 power. So then when finding the derivative, let's use the power rule to get 1/2 times x to the 1/2 power minus 1, which is going to be 1 over 2 root x. Now f prime of 4 is equal to 1 over 2 times root 4, which is 1 over 2 times 2, or 1/4. Wonderful. Finally, what is our original function f evaluated at 4? Well, the square root of 4 is just 2. So the line tangent becomes y equals 1/4 times x minus 4 plus 2. Okay, well, why does this matter? For that, let's look at our technology. Please open up GeoGebra. And if you notice, I already have this graphed out. And let me change my view a bit. So let's zoom in. So why does this tangent line matter at all? Well, if you notice, if I zoom in really close to my point, there we go. As I get closer and closer here, and bear with me while I get a better view. Look at this. At values really, really close, that is values really close to this point, you notice the tangent line in black looks really, really similar to my function in green. So the tangent line is actually a really good approximation of a function at a point. So we can use a linear approximation to get a fairly close value of f at some point, say A. Now if you notice at the top of the next page, I've reiterated what I've said. The tangent line can be thought of as a good approximation to a function at x equals a.